Hi, my name is Jamal Robinson. I'm a cloud solutions architect. I want to provide an introduction to OpenStack along with demonstrate some of its capabilities. OpenStack is a free, open source software platform for cloud computing, mostly deployed as infrastructure as a service. The software controls large pools of compute, storage, and networking resources throughout a data center and manages it through the OpenStack API or a dashboard, which I'll show here shortly. It's been around since about 2010 and has gained a large adoption. A lot of companies across industries use OpenStack. An example of some of those companies are Yahoo, Google, Cisco, Telefonica, IBM, VMware, Lenovo, Wikipedia, Intel, American Express, Red Hat, HP, Dell, BMW, NASA, Disney. The list goes on. If you want to see who's using it and how, it's good to check out the OpenStack.org website as they give you additional information. If I click on Users, you can see the list of companies using it here, also along with some case studies that are very valuable for you to read and understand what the companies are doing with OpenStack and how potentially you could do the same thing. OpenStack also has a lot of projects. I mentioned the dashboard, which is called Horizon, but there are other projects for OpenStack too. On this site, you can use the Project Navigator, which shows you the core services for OpenStack along with other projects and their name. It's also beneficial to look at the adoption percentage, which means how many OpenStack deployments are out there and what percentage of them adopt this project. At the top, you can see the key projects that have above a 90% adoption rate, but then there's some other projects below that don't have a 90% adoption rate, but may or may not be applicable to your OpenStack installation. OpenStack also has a documentation page. On the doc site, you can get valuable information about how to use the APIs, different things to consider when using OpenStack with different operating systems, and things like administration user guide. Although we started off with a little documentation and background of OpenStack, I primarily want to show you the Horizon dashboard and how to utilize OpenStack through that. So let's get started. I want to start with identity. Identity handles identity and access management, no surprise there. And this tab for the identity represents the Keystone project that I mentioned earlier. It's used to create users, groups, project, policy management, and handle authentication for OpenStack's catalog of services. What that means simply is that it will authenticate your user against their action. So if you have a user that's trying to delete a router, then Keystone is responsible for verifying that the user has permission to do so. Same thing with another user trying to create a new project or another user trying to add a user to an existing project. Keystone manages who has what permissions. In the OpenStack user interface documentation, a group of users is referred to as a project or tenant. These terms are interchangeable. For new users, I normally say that this is a project, but just as an FYI, you want to know that people also refer to this as a tenant, so you don't get confused when you hear that. View a project is kind of a group of virtualization resources. The best example I can think of is, say you have a company like Coca-Cola who owns multiple brands. Coca-Cola may have a project for each one of its individual brands on its OpenStack deployment. So Dasani will be one project, Sprite will be another project, or Honest Tea will be another project. Or they could give each one of their companies their own OpenStack deployment. So let's say Sprite has its own, and then within Sprite's OpenStack deployment, they may have a project for the human resources team. They may have another project for their marketing team. They may have another project for their sales team. And this is just a way to logically separate different virtualization capability between teams. That way you can allocate more for marketing, less for sales, or however you need to allocate that hardware. So let's create a new project. I enter the project information. Then I go to choose the members that I want to add to this project. For this purpose, I'm going to add demo and I'm going to add admin. And I'll give them member privileges. For admin, I want to give it administrative privileges. These privileges are tied to the ability to execute different commands or roles. Depending on your setup, your roles will be different. So if I'm using a hosted cloud service as IBM's OpenStack, they'll give you a different set of permissions and different role names. So I've navigated to IBM's managing users and permissions. So if I'm using IBM's cloud, you can see that Cloud Admin has the ability to create a user, but Member does not. If I was using Red Hat or another cloud vendor, they may change the name. You may not see a cloud_admin. You may see Red Hat_admin or Red Hat-admin, and the permissions will be different there. OpenStack allows you to customize the roles as you see fit. So for right now, I'll let my demo user remain as a member and my admin user remain as a member and an admin. I also have the option on project groups to add a group. What this does is allow me to manage a group of users. So if I had 15 admins, I could add all 15 right now and give all 15 the admin permission. If something happened and for whatever reason I needed to remove the permission for an admin, I could come here and say, okay, let's no longer make them admins. This allows me to add it to all 15 users at once, rather than under the Project Members tab, I'd have to go through each one of the individual 15 users. Then we get to Project Quota. Project Quota allows you to slice up virtually the physical hardware that you have. So OpenStack is sitting on physical compute nodes, which let's say have 200 CPUs. So here's where I can say that this project, I wanted to only utilize 20 of those 200 CPUs, leaving 180 for other projects. Same thing with instances. I can set how many instances are launched, how many volumes or snapshots or backups of those volumes, along with the total RAM allocated for that project. Right now I'm going to leave the defaults and click Create Project. Now my project has been successfully created. Now that I have the project, let's add a new user to it. I click Create User. We'll call this one Test User. For the primary project, meaning the project that the user sees whenever they log in, we'll choose Test Project, and we'll leave them as a member. Now my user has been created. So let's log out and log in as the test user. Now notice that I've logged in, and under my projects, I only have one project listed, which is Test Project. I know that I'm the test user because it shows me my user on the right hand side. And then now if I try to take a look at identity, notice that I only have projects as an option. Because test user is not an admin, test user only has the ability to see its project. They can't edit the project, they can't add new users or anything else. This, as we stated before, is defined by the roles, as the roles determine what permissions this user does and does not have. You can set permissions based on a project level, where all users in the project have certain permissions, or you can set it based on an individual user level. One thing this member level user does have is permissions over itself. So you have the ability to go to settings, and you can change your own password and change things like the time zone and the number of items shown per page. Let's log out of test user and go back to admin. So we've covered the administration of users. Now let's cover some administration of the compute resources, starting with Hypervisor under the System tab. Hypervisor shows me the available statistics for however many hypervisors I have in my system. A hypervisor is a virtual machine manager, or you can view it as software that allows multiple operating systems to share a single hardware host. There are different types of hypervisor software that work with OpenStack. Right now I'm on the OpenStack.org's wiki, which shows the hypervisor feature support matrix. You can see some of the popular hypervisors here, such as Zen and Microsoft's Hyper-V. In this case, you can see that my hypervisor has 8 virtual CPUs and 16 gigs of RAM total. That's because I'm running this on a smaller machine for purposes of this demo. If you were really looking at an OpenStack deployment, you might see anywhere from 256 virtual CPUs and terabytes of memory, as the machines that normally run OpenStack have a lot of resources available to them. You also have the ability to overcommit these values. What that means is for every one physical CPU, you can use 2 virtual CPUs. This is beneficial when you have programs that don't run at 100% utilization of CPU and memory at all times, and that way you can get more virtual CPUs, knowing that each one of your virtual machines won't use the actual physical CPU to its full capacity. If we look at instances, this shows every one of our virtual machines across all projects. This is beneficial to an administrator because if you're logged in as an individual project admin, you can see what's going on in that project, but you can't see what's going on in all projects. And this allows you to have that view of what virtual machines are in what project and what compute resources are they taking and how long have they been up. It's also beneficial for instances where, let's say, you have a series of 10 hypervisors and you want to migrate one of those hypervisors to newer hardware. You can look at all virtual machines that are on that specific hypervisor and migrate them to the new hypervisor before shutting it down. So on the Flavors tab, you see different templates for your virtual machines. Whenever I launch an M1.small, I know that my virtual machine will get 2 gigs of memory and have a 20 gig root disk. You can create your own flavors to customize this how you see fit. Flavors are just a way to slice up compute resources and template those, so every time you launch a VM with that flavor name, you get the exact same set of resources. The Defaults tab shows you what defaults are set for a project, so whenever you go to create a new project, these are the defaults that it'll get. You can change this, and that way you don't have to go through and change each and every project that you launch. The Host Aggregates tab shows host aggregates along with availability zones. The simplest way I can describe this is with a graphic. This graphic shows the difference between an availability zone and a host aggregate. So imagine you have 7 compute resources. An availability zone is a theoretical zone that you want those compute resources to live in. A host aggregate is how you group those resources. So in this example, you can see I have what I call a host aggregate of SSD, meaning that compute 1, 2, and 3 I know have solid state drives in them. And then I also have a high frequency CPU host aggregate, meaning that these 2 compute resources are using an advanced CPU. Notice that compute 2 has solid state drives, but then also has high frequency CPUs, so it fits within 2 host aggregates. The benefit of setting this up allows me to execute virtual machines that I know need high frequency CPUs on the high frequency CPU host aggregate. The ability of availability zones is it allows me to set up my compute resources in potentially different regions. So if I have a data center on the East Coast, I can make that availability zone 1, and then I can have a data center in the West Coast and call that availability zone 2. For the purposes of a host aggregate that has a high frequency CPU, if I needed to make sure that this was a highly available application, I could deploy on compute resource 2 and compute resource 4, knowing that if the data center in the West Coast went down, I still have a data center in the East Coast running the same hardware with my virtual machine. So that's it for a brief introduction to OpenStack. You've seen in this video how to create a project, create a user, and how different permissions affect what a user can or can't do on OpenStack. In the next video, we'll want to cover some common compute tasks like launching a VM, setting up security groups, and backing up your data with Snapshot. Thanks for listening and hope this was helpful.